Hello students. Now that we know what a polynomial is and what a binomial is, we're going to start using them, and today we're going to use them in equations. But there's a property that you need to know first, and it's called the zero product property. Zero product property. The zero product property says that if you have A and B and A times B equals 0, then either A equals 0 or B equals 0. What this is telling me that is if I've got any equation that equals to 0, then one of these factors must be 0. Because in order to get the answer of 0, I have to multiply something by 0. So if I'm multiplying two things, it could be two binomials, it could be two whatevers, then one of them has got to be equal to 0 in order for my equation to be 0. So how does that come into play when we work with binomials? Well, let's say, for instance, that we have the quantity of x plus 14 times the quantity of x minus 3 equals 0. Well, then I would know that one of these has to equal 0. So in order for, let's say, this first factor, x plus 14, to equal 0, then what does x have to be? Well, x would have to be negative 14 in order for this to equal 0 to multiply this to get 0. Well, what if I said that x minus 3 was 0? Then what would x have to be in order for this binomial to equal 0? Well, it would have to be positive 3, because 3 minus 3 is 0. So then the next question is, well, how do we figure that out? How do we write those things? Well, whenever we have two binomials or a set of polynomials that equals 0, then we set up two different equations to make each one of them equal 0. So I'm going to erase a little bit and start over so you can see. So we have x plus 14 times x minus 3 equals 0, then I would set it up into equations. X plus 14 equals 0, or x minus 3 equals 0. And if x plus 14 equals 0, then x equals negative 14, or if x minus 3 equals 0, then x equals 3. So the solution to this equation, including binomials, is x equals 14 or 3. So those are the two possible solutions to that equation. So let's look at this example. I have the quantity of 3x plus 9 times the quantity of 6x minus 3 equals 0. Well, that tells me that one of these quantities has to equal 0. So again, I'm going to set up the two different equations. And those are going to be 3x plus 9 equals 0, or 6x minus 3 equals 0. And so we're going to solve them. 3x equals negative 9, so x must equal negative 3, or 6x equals 3, so x must equal 1/2, because you divide both sides by 6 and you simplify to 1/2. So the solution to this equation would be x equals negative 3, or x equals 1/2. Now, before we keep going and solving these equations, there's something new that we've got to learn, and that is finding the greatest common monomial factor of a polynomial. Now, let's break that down. The greatest common factor we've learned before is a number that can go into both numbers. Well, the greatest common monomial factor may not just be a number. It could be a number and a variable, and that variable could have an exponent. So we've got to figure out what is the greatest monomial factor of each term in the polynomial and then factor that out. So let's look at 8x plus 12y. Well, in this case, we're going to start with the coefficients. What is the greatest common factor between 8 and 12? And you know that from a long time ago, that is 4. Now, is there a greatest common factor between x and y? And the answer to that is no, because they are different variables, and so there's no greatest common factor. So the only greatest common factor I can get here is 4. So now what I'm going to do is divide each of these terms by 4. So it's kind of reverse of the distributive property. So 8x divided by 4 is 2x. and 12y divided by 4 is positive 3y. So this is my greatest common monomial factor, and here is the other factor. So I did 8x plus 12y divided by 4, and I got 2x plus 3y. Well, let's slide over to this one over here, 14y squared plus 21y. Again, we're going to see, is there a greatest common factor between the coefficients, which would be 14 and 21? And I know you're thinking in your head, and you're thinking, yes, Mr. Cohens, that factor is 7. Well, the next thing is there a greatest common factor between y squared and y? And the answer is absolutely. They are both the same variable. They have different exponents, but they're both the same variable. So here's the clue to finding the greatest monomial factor when we're talking about variables. It's always the variable with the smallest exponent. I'll say that again. The greatest monomial factor always includes the variable with the smallest exponent. So here I've got y squared and I have y. They're both the same variable. Which one has the smallest exponent? Well, obviously that would be y. Okay? Because y can go into y evenly and y can go into y squared evenly. And we're going to see that in just a second. So my greatest monomial factor of this binomial is 7y. So I'm going to divide both terms by 7y. So 14y squared divided by 7y is 2y, because 14 divided by 7 is 2, and y squared divided by y, same base, subtract the exponents, 2 minus 1 is 1, so it's just 2y. Plus 21 divided by 7 is 3, and y divided by y is 1, so it's only 3. And I could go backwards and say that 7y times 3 is 21y. So when I factor out the 7y, I get 2y plus 3. So the last part of this lesson is solving an equation by factoring. So we're going to take everything that we just learned and put it all together. So I've got a squared plus 5a equals 0. Well, the first thing I've got to do is factor out that greatest monomial factor. And I've looked at my coefficients, and my coefficients are 1 and 5, and I know there's not a greatest common factor besides 1, so we don't put 1. And then we have a squared and a, and from what we just learned, the variable with the lowest exponent would be a, so a would be our greatest monomial factor. And now I divide each term by a. A squared divided by a is a, and 5a divided by a is simply 5, because the a's cancel out and I'm left with 5. And we know that that equals 0. Okay? So if I just went back to check, a times a is a squared, and a times positive 5 is positive 5a. So we're good. But now I've got to figure out what does a equal. So I have two polynomials. This one's a monomial, this one's a binomial, and I set up two separate equations to figure out what a equals. So in the first one, a is going to equal 0. Well, that was simple. And the second one was a plus 5 equals 0. I forgot the or in here. So if a plus 5 equals 0, then a must equal negative 5. So the answer is 0 or negative 5. So if I plugged in 0 here, I'd get 0 plus 0 equals 0. That would work. If I plugged in negative 5 squared is 25, because it's a negative 5 that's squared. And then 5 times negative 5 is negative 25. So 25 plus negative 25 is 0, so it works. Well, let's look at this other example. 3s squared minus 9s equals 0. Well, I've got to figure out my greatest monomial factor. And what's the greatest common factor between 3 and 9? And that answer would be 3. And then, what is the greatest common factor between s squared and s? And by now you figured that out, that it is s. So I'm going to divide both terms by 3s and see what I come up with as a binomial. 3s squared divided by 3s is simply s. Because 3 divided by 3 is 1, s squared divided by s is s. And negative 9 divided by 3 is negative 3. S divided by s is just 1, so it would just be s minus 3. Now if you want to work, and do the distributive property just to make sure. That'd be a good idea. 3s times s is 3s squared, and 3s times negative 3 is negative 9s. So we're good. Now I need to set up two equations. 3s equals 0, or s minus 3 equals 0. Well, if 3s equals 0, then I divide both sides by 3 and get s equals 0. And if s minus 3 equals 0, then s has to equal positive 3. So my answer is s equals 0 or 3. And those are the two solutions. And here are your 4 practice problems for tonight. The first one is n minus 8 times the quantity of n minus 9 equals 0. So solve for n. The second one is 4x plus 5 times the quantity of 4x minus 5 equals 0. So you'll solve for x. The third one is 4s squared minus 14s equals 0. So you'll have to factor out the greatest common monomial factor first and then solve it. And then the last one is a little bit different than you've seen before. It's 8c squared equals 4c. So I'll give you a little hint. You got to first put everything on the same side. Then factor out the greatest monomial factor. Then solve for c. Please make sure you take a picture of these problems and submit it using the submit button or the turn in button in Edmodo, and we will go over them in class the next day.